All right, so we've been doing, we did one-way between subjects and ANOVAs. We did two-way between subjects and ANOVAs, one-way repeated measures, two-way repeated measures. Now we're going to mix and match and do mixed ANOVA. So this is the last sort of ANOVA example. I'm not going to spend a whole lot of time talking about how they calculate degrees of freedom and sums of squares because it just all goes to hell at this point. So for that portion of the in-class test, really focus on how is between subjects and repeated measures the same. So like the basic mean minus the grand mean, level minus mean kind of focus. That's what I'll test you on. Okay. So mixed ANOVA, unsurprisingly, is half and half. So at least one variable is repeated and at least one variable is between subjects. So we use mixed to do any type of combinations. If you have two repeated and one between, it's still mixed. And that's what you'll call it, is a mixed ANOVA. So you got between subjects, that implies everything is between. Repeated, that implies everything is repeated. Mixed is I got some of each. Okay. Dr. Mitchell really loves to talk about this kind of stuff. And he'll have you talk about three-way interactions at some point as a mixed design. So getting a feel for like which is repeated, which is between, it's going to be important. So I'm just gonna jump right in. Okay. So data screening, still accuracy, missing outliers, do all that in long format. Okay. For your assumptions, you still have to deal with additivity because you're going to have multiple measures of the repeated component, but that rule is 999, and that's just mainly sort of run. Okay. So if your two repeated components are perfectly correlated, it won't run. So it's a slightly different rule than your normal multicollinearity issues. It should be normal, it should be linear. Now for homogeneity, we've got to do both. We've got to do Levene's for the between subjects component and Mauchly's for the repeated measures component. So this is like take everything we've been doing so far and do it all at once. That's essentially what happens here. And then homoscedasticity is still an issue. So the example from the book is speed dating. So we're going to look at personality of the person they're talking to. You guys know how speed dating works. You know, we go around the room and talk to a bunch of different people. It's like, I guess consider this tender in person. So does personality of the person you're talking to, not the personality of the rater, and gender of the person that's doing the rating interact? So we've got one personality, IV. So they're going to interact with people who are high charisma, some charisma, or no charisma. So basically different levels of appeal personality-wise. And then gender is the gender of the person who's doing the speed dating. So are they male or female? Okay. Yeah?
Didn't we before do data screening in wide format? So I guess with mixed data.
Oh, crap. That's totally a typo. Yes, thank you. Yes, you should. It wasn't even late, so I got to blame it on something else. I'm a scatterbrain. Yes, wide format. I was doing this at the same time I was making sure that MLM lecture was understandable, so I think I got my wires crossed. Yes, wide format. So you don't want to switch to long format until you get to screening for Mauchly's and Levene's. At that point, you'll have to switch. Thank you. Good catch. Okay. The dependent variable in this experiment is your rating of the person or the date. So 0 is no way, not happening, to 100%, let's match or whatever. Okay. So our personality variable, since we're seeing one person of each of those types, is repeated. But our gender variable, the person who's doing the rating, can only be male or female. So that's what makes this mixed. So gender is our between subjects variable. And personality is our repeated measures variable. That means, just technicality-wise, you have to melt personality but leave gender alone. Okay, so what we've been doing is melting everything and then dealing with the columns being multiple variables at once. But now we just have to melt personality. So these are actually going to be a little bit easier than double repeated measures. until we get to simple effects. And they're not hard, you just have to figure out which way you want to analyze. So you still do have to have a participant number. It still has a repeated component. So anything with repeated measures has to have a participant number so you can control for it. But we won't have to create these new variables. So in our double repeated measures, we had to take that one column that was all the conditions and make IVs and IVs. Since we only have one repeated, it's just one column. Unless, of course, you have multiple repeated measures, and then you still have to do that. So let's try it. So in my data set here, yep, that's nice. Let's make it bigger. Let me set my working directory. Cool. All right, so I'm calling this file mixed. So what I have in the mixed data set is stupid import problems. But anyway, so I got gender of the participant doing the rating, and then their ratings for all three types of people: high charisma, medium, and no charisma. So we're hoping that charisma creates a larger, higher percent rating of the date, right? So you should be attracted to or want to date people who have more charisma, you would think. Okay. But we're going to see if that is a difference, if there's a difference in that effect for men versus women. So because this is being stupid, I have to fix the column names. So if you just did that, it's capital G gender to make the rest of this code work. All right, so the next thing I did was I added a participant number. That's the same code we did last week. I just changed the name of the data set, so that hasn't changed. So now I have part new out here on the side. Pretend like we've done all of the different data screening, and so now we're at the point where we want to do Levene's and Mauchly's. I never can remember that I have to install these when I get to class. It distracted me with marshmallows. I'm also easily distracted. So.
Maybe I shouldn't put marshmallows on.
Yeah, I'm like, ooh, it's orange. Okay. So I'm going to melt that, so it's data set. Remember, now I have two of them here. So before we've been melting with either none or just participant number, but now I want to leave gender in there. Okay, otherwise it will melt gender, or sometimes it'll ignore gender, so you don't want to do that. And then my three charisma variables. So for my long data set, I now have participant number, IV1, which is between subjects, IV2, which is repeated measures, and DV. So it ends up being nice and pretty. Here's the problem, though. The next thing I did was I fixed the column names so they're useful. Also, so I wouldn't have to do too much relabeling when I got to my graph. But then I also applied some of our refactoring stuff that we've done a couple times that I still think is probably kind of a little iffy for most people. So what I did was I said, okay, I'm going to factor this charisma variable because it should be none, medium, high. This is something that is a trend. So we could do trend analysis if we want. We're not. But okay. So I took the name of the levels that are in the data set naturally. So none char, me char, high char. So remember, if you have the levels command, it has to match what's in the data. And then I relabel them, none, medium, and high. So I wouldn't have to label them on the graph later, and reordered at the same time. So this accomplished two goals. It renamed them and reordered them. So it has to match what's in the data set. Okay. So what's in the data set are these names, but you can reorder them. So you don't have to label them and then reorder. You can do it at the same time. And always, just to make sure that you're doing it correctly, because I totally screwed it up when I did it the first time, is after you run it, you can do the table command just to see that there are still people in there. So sometimes, I know everybody's gotten that error where it's like 0 by 0. You run the wrong one, or you've wiped your people out. So that's just things taken out of context in this class. Like, really should be keeping track somewhere. Just tell me all of them at the end of the year. I know everyone has done this once. I mean, I did this making this code. So just when you get that error, always check and make sure there are people in your data set and people in your levels. Okay, so that's generally the issue. Okay, all that work to now get to, can I run Levene's? So do I have car? No. Don't forget that's in the car library. Oops. There we go. So, I know it's been a little bit since we've done between subjects. So remember, it's Levene test. Y is approximately X. So rating is my DV. Gender is my between subjects variable. Leave the other one out. It's repeated. If you don't, it'll treat it like it's between subjects and analyze it for Levene's, which we don't want to do. So we're just totally leaving it out right now because it's not between subjects. Data equals the name of the data set, so mixed long. Center is with the mean. Be sure you include this, or it'll do a median center, which you don't want to do. So run that. Should give you this. So it tested Levene's test for gender. So it's just labeled group on the side, but that's what it is. And it is significant. No. So what we would actually have to do, if you wanted to correct for Levene's test, is a robust weighted ANOVA. And that is explained in way too much detail that I'm not entirely sure I follow in the end of chapter 14. So if you get yourself in that situation, here's the marker where to go back to. I'm going to show you the, I don't care route. Because what happens is you lose power. Okay, so when your variances are not equal, you just don't have the same, your power gets lower. And we've said this a couple of times, we're okay with type 2 errors. But if you wanted to do a weighted robust ANOVA, it talks about it a lot in that chapter. All right, so for Mauchly's test, so we've done Levene's, it was bad. Now for Mauchly's, we're going to do the ezANOVA. You won't see the between subjects piece analyzed because it's not repeated. So Levene's is only between, Mauchly's is only repeated. Okay. You will get the information for the interaction though, because it includes a repeated piece. So you will see gender on there, but it's because it's part of that interaction. So it analyzes conditions as well as levels. So here's the new thing we have to do. So I've got my data equals data, DV equals rating, within subject's ID is participant number. Within is your IVs for repeated, and then here's the new line. Between equals between subjects variables. Leave detailed equals true, type equals 3 alone. And remember, everything on the left side here has to be those words. Everything on the right side is what's in your data set. So from last week, all we've done is add in the between subjects line. So I also turned off scientific notation because I look at it and I'm like, oh, brain hurts. Okay, so let's run that and look at the output. So the first thing I did here was just copy Mauchly's. So I've got charisma and gender by charisma. So there's no gender by itself because it knows it's between subjects because you put it in the between subjects line, so it ignores it. Neither of those are significant. It's very odd for them to be exactly the same. I think that's because this is made up data. I was like, what did I do? Hopefully you have the same numbers I do. We're not going to have another week like that. But that's unusual. But okay, so it's non-significant, so we don't have to worry about it. If we did, we would clearly be using Hunfeld because the estimate is over 0.75. It's also, I don't think, supposed to go over 1. So I don't know what I did, but you wouldn't correct. I don't think epsilon's supposed to go over 1. I've never seen it go over 1, but who knows. The other thing you'll get is the output for the ANOVA. At this point, you've looked at how many of these? I've done 4 different design types, so hopefully this isn't confusing. It looks just like last week's. So really, the only difference between double repeated and mixed ANOVAs is make sure you get the right variable in the right line. Here. It will not look any different in the output, but the math is different. So just making sure you have them in the right line so that the math is correct. Otherwise, your output is useless. But if I look at these, their gender is not significant, so there's no difference in overall ratings between genders. Charisma is significant, which we expected. We expect there to be a linear trend, right? Low should be the lowest and high should be the highest. But then there's also an interaction, because otherwise why we're doing this example, between gender and charisma. So I wrote all those out for you guys. So it's still eta squared. I think it's generalized eta squared, which is slightly different than regular eta squared. So at some point you might want to say it's generalized eta. I'm trying to figure out the math, but it is so close I can't figure out exactly what they're doing. And I haven't read the article because, you know, I got better things to do, like make incorrect notes. So we got a main effective, the main effective gender is not significant. Okay, good. This is also an example of how you might write one where f is less than 1. Okay. Sometimes what you'll see people do is just write f, just the letter. I'm not a huge fan of this because it doesn't tell me the degrees of freedom. So I can't tell if that's a power issue or if you even know what you're talking about. So always leave in the df. Some people don't. You'll see it written like this as well. All right. So if I wanted to analyze just the main effects, so pretend for a second the interaction isn't significant, what would I do? Well, I tried to spell this out like super clear. If it's a between subjects variable with more than 2 levels, so not gender. Gender has 2, I wouldn't do anything. I can go back to my between subjects notes and do the agriculture library. That's probably the easiest thing. It's like 2 lines of code. So I'd run the ANOVA, excluding the repeated measures variable. So this is a main effect, so we'll just totally leave that variable out. And then do one of the 4 different corrections we talked about. You can also do pairwise.t.test, Bonferroni. Or you can do the LME Tukey option. I bolded the one I thought was probably the easiest. A lot of you like pairwise t-test, but you got to remember it's pair equals false. So any of those 3 options would work. For repeated measures variables with more than 2 levels, okay, if you only have 2, just look at them. You can do pairwise t-test or the LME functions, just like we did last week. But we don't care. Main effects, whatever. Let's talk about simple effects. But I can apply that idea to get what I'm interested in for the interaction. So with interactions, you always have to split first. Like, you can't avoid it. I'm sorry. It's just not a thing. So I've got to split up my variables somehow on the larger one. I know that's more lines of code, but it creates less post hoc, so give you more power. And in the grand scheme of things, you always want to run less tests to get more power to be able to publish it. So more lines equals more power. So we want to split on charisma, which it's got 3 levels. The hard part, though, is you've got to think about which way are you splitting. I have this drawn out here in a second, but I'm going to go ahead and draw it. So if I've got gender and none, medium, and high, I've said that probably I want to split this way. So this is my split variable. Where's the I? Split. This is my analyzed variable. So if you sort of, you don't have to draw this, but if you write it out or type in your notes or something, that way when you're running the analysis and you get that 0 by 0 error, make sure it only has the analyzed variable in it. Okay. So don't run an analysis on a variable you split. Anyway, okay, so I have to pick one to split, one to analyze. And then where I'm going is a couple slides from now, this picture. Is if I split going this way, I'm comparing men and women. If I'm comparing men and women, that makes this between subjects. If I split this way, and I'm comparing none to low to high, that's going to be repeated measures. So you got to think about who am I comparing. If I'm comparing men and women, it's between subjects because I can only be one of those. If I'm comparing none to medium, none to high, medium to high, that's repeated measures because I'm in all three of those boxes. So you have to think about which way am I splitting, so which test should I run? I feel like this is the easiest thing to screw up is this section because in R, it just has IV and IV columns. It does not make the distinction between repeated and between. You have to know that. It's a little harder in SPSS because the way it's structured, you pretty much can't run the wrong one. Well, you can. It gives you some really funny answers. I have had people do it, but generally 3 brain cells are on and you're like, wait, this is wrong. So make sure you understand like which way am I going. If you want to do between subjects, so you can do the AOV agriculture library, you can do pairwise t-dot test, paired equals false. So this is the important piece. Or the LME test. Okay, that's the exact same slide I covered a minute ago for main effects. You would do that on each of the split data sets. If you're going to do repeated measures, same thing. Pairwise t-test, paired equals true, because that's the only way that it knows. This is between, this is repeated, or LME. So here's my quick push for why I like the LME options. Because I don't have to think about which one it is. It just is. So I don't have to remember if it's paired or between. I mean, I should because it's my own research project and I should know what my variables are. But you would not believe how many times I've had somebody sitting in my office and I'm like, okay, is that repeated or with it or between subjects? And they're like, I don't know. And I'm like, how do you not know this? It's your thesis. So I'm like, okay, do they take all of these? Yes. Okay, it's repeated. So I'm like, oh, why? So there's a way that you don't have to remember things. I like that. Okay. Plus, after this test, we're going to cover regression. So once you get a hang of regression, you could actually never do an ANOVA again. It's nice, yes. Which I feel like that's slowly where we're going is with repeated measures is just ditching ANOVA altogether and just doing everything as LME. But I felt like if I taught you guys that, your advisors would probably murder me. It's already bad enough that we're doing R and they aren't all on board. But it is rather different. So when we get to mediation and moderation and regression, we'll talk about how this is ANOVA. So we'll come back to this. So my small push for why LME is the best option. It's not the shortest, but then I don't have to remember paired equals true, paired equals false. All right, so since gender has a smaller number of levels, we're going to measure that way. So we're going to analyze between these two, so I only get 3 tests instead of 6. So I'm going to split my 3 repeated measures into different data sets and then analyze on male and female, which is independent T. And then I made a pretty graph. So what would we expect to have happen? So why is there an interaction? Well, if you're looking at no charisma, females are rating much lower than men. If you're looking at medium charisma, they're equal. And then at high charisma, it's flipped. So this is almost a perfect interaction. Okay? Because the effect on one end is this way, they even out, and then they switch. Okay? That's not totally a perfect interaction. because these two need to be up here for it to be perfect, but it's close. So you're getting that interaction because for none, females are lower. For high, females are higher. Or you can think about this as guys is pretty much all equal, but girls is a big effect of personality, which is supposed to be kind of a joke. Like the men are like, I don't care, whatever. The breathing, right? This is definitely not my data, but it's a funny joke. Okay. So what I'm going to do is I'm going to show you all three ways. Pick your favorite. Don't do all three. Pick one of them. But I will show you how to run this in multiple ways. All right. And that's, I'm going to skip the plot so I don't have to install ggplot because it takes forever. But I included the code for the plot. So we're going to split first on the larger variable. Always check over here and make sure that your split data sets have people on them, that you spelled everything correctly. So high, medium, and none each have 20 people. Okay. Because there are 10 in each gender and they rated every single person, so there's 20 lines each. If I wanted to run the ANOVA option, I would first install the package. And this has been a while since we've done it, so a reminder of what's going on. So I've got AOV, so run on ANOVA. Y is approximately X. I have left out charisma because I split on it. So don't include a variable, don't include the split. Okay. And then 3 different data sets. So you have to run it 3 times because you have 3 different groups. So 1, 2, 3. Okay. That's just a temporary placeholder. So now I can do hsd.test. So that's Tukey. Remember, lsd.test can be Bonferroni if you include some extra code, SNK, and Chefe. So you have more options. And then you would just run those to get your differences. One reason I like this option is it gives you the means. So that's, I know that's been several weeks now. So remember, this one gives you the means. So this would make effect size a little easier. So the first one is significant. The p-value is not 0, but it's very small. The second one is not significant. There's p. Here we go, 0.75. And then the last one is also significant. Okay. So that's Tukey using the agriculture library. The second option would be the pairwise t-test option. And I used the with function just so I could not have to do $signs. Remember, it's dv, comma, iv, paired equals false, because this is between subjects, and then p-adjust method. So I could run all of those. And in an effort to keep straight what was going on, I made a table, because I like tables. Right? So Bonferroni gives me the exact same results. And you, as most of you have been doing this option for your homework. So you just look here, that's their p-value. Okay, it does not give you the means. Lame. Okay. So 0.75, 0.001. So you get more decimals so you can see what the 0 means this time. And the last option is the LME function. Yeah, that's fine. That one went really fast. All right. What? Why? Did I install the wrong one? And LME successfully unpacked. Haterade. Okay. That's a new one on me. And, okay. Who knows? Sometimes run it again. So, what you do is LME for linear mixed effects. Y equals X. Here's that random thing. So it's controlling for participant numbers, so the participants are in there multiple times because they have 3 different measurements. Okay. If in this case, when I split the variable, now they're only in there once. Okay. So it's each participant. So at this point, it is only between subjects. So they're not really in there multiple times, but I can control for it so I don't forget in case I have multiple variables. Change the data set on each one. So I'm running it 3 times with 3 different data sets. So it's just a lot of cutting and pasting. I never realized how many packages this requires until I'm typing it out. There we go. And then what I would do is run the Tukey. So just like the agriculture library requires me to run ANOVA and then Tukey, LME requires me to run regression and then Tukey. So it requires 2 steps. The only one that doesn't require 2 steps is pairwise T. So then I would run those and get the summaries. So remember, this weird funky word, linfict, stays. The only thing you change here is the gender. So whatever the name of the variable is. Okay, that's the name of your IV. Okay, so that's your analyze variable. And then we've got Tukey. You guys have looked at this too. So here's my Z value. Again, the second one is not significant, 0.74. And the last one is significant. And that is what this table has in it. So I have 3 different options. Pick your favorite. Whichever one makes sense to you. I know you guys don't like multiple options, but pick your favorite one. If I had to bias you towards something, it probably would be LME, just because that will apply to other things we're going to do this semester. If I had to tell you which one was the quickest, it's probably Bonferroni, because it doesn't require 2 steps. If you wanted to run something other than Tukey or Bonferroni, the agriculture thing would be the quickest. But it gave me relatively the same results. So that's where I'm saying pick your favorite. Then when you are writing this up, and you guys should like give me an award today for finishing so quickly. Be sure you tell me what type of ANOVA it is. So it's a 2x3 or a 3x2, either way. Mixed factorial. Or you can just call it a mixed ANOVA. But you still got to include that word of what type is it. So I got between, repeated, or mixed. For some reason, people always say mixed factorial together, even though we've talked about factorial is not a useful word because it implies multiple variables. You have 2 main effect F values, 1 interaction F. Which type of post hoc and correction did you use? So independent T in this example with Tukey. Your post hoc values, you got P and then Cohen's D. And that will really depend on which way you go. So if you do independent T, it's Cohen's D. If you do dependent T, it's D average or D diff. And then a picture. And so really, like, today is not super long because it is a mix of the 2 things we've been doing, hence the mixed ANOVA part. So I think the thing people forget, don't forget Levene's. We've been doing so much sporicity, it's easy to forget Levene's. And then when you get to simple effects, make sure you understand which way you're going. So if you're going across the between subjects, do independent T. If you're going across repeated measures, do dependent T. Or if you want to remember neither of those options, do LME. And that did not mean to rhyme, but it did. So, all right, pause that. So, repeated measures. Right, the test family is going to be F. Well, that's not an F. Let me do this. Okay. So, it's still F either way. And that's true for between subjects as well. The next option is statistical tests. So for repeated only, you go down to repeated within. So it's repeated measures within factors. And the way I always remember this is repeated is said twice. It says repeated measures within, but remember those are the same thing. So we're interested in repeated measures. We'll do the other side here in a second. A priori stays the same. your effect size F, what you want to do is hit determine. So I'm going to hit determine or just guess. You can click direct and enter partial eta. So we can enter that generalized eta. Let's pick a random number. So let's do 0.10. Let's do a small one. 1, 6, 14, somewhere between medium and large. So calculate and transfer to main. Alpha is always 0.05, leave it alone in our field. Beta is always 0.8. And this is where it gets tricky. So number of groups is technically number of groups, literally. Okay. But if you're doing all repeated measures, that's 1. So this is like the number of between subjects variables, which is a little weird because this is all repeated. So generally you want to leave that one as the number of between subjects variables, or sometimes people list it as the number of repeated IVs. So if you have 1 repeated measures IV, it's 1. If you have 2, it's 2. Number of measurements out here is the number of levels. So this is going to kind of depend. So let's do number of groups first. How's the number of IVs? And the number of levels is either literally the number of levels or the number of conditions. Why conditions? Well, generally we're interested in the interaction, or why are you running multiple variables in the same experiment. So the number of measurements is now how many conditions are there total. So I can do a simple effects analysis. So in the study we just did last week, what did we have? 3 by 3 was like beer, wine, and water, positive, neutral, and negative. So I could do 3 here and 3. Oh, sorry, conditions, 9. 3 times 3. Correlation among representative measures. I've already over. Sorry. Is the lowest correlation between conditions or levels. So if I have 9 conditions, I would pick the lowest correlation between them. And you want to do the lowest one because we want to overestimate the number of people you need to hit power, not under. If you aren't sure, leave it at half. A half is like a good medium guess. Generally, since you're testing people multiple times, the correlations are in the 0.8s. So the higher the correlation, the more power you have. If you don't know, leave it at 0.5. But it would be the lowest correlation between conditions. The non-sphericity correction is epsilon. There we go. So that's where your Hunfeld or your greenhouse geyser number comes in. Under Mauchly's. If you are doing this totally a priori, which is what you should be doing, you have no idea, leave it as 1. That's generally not something you know. The lower that number gets, the more people you need. All right, so if I hit calculate, I would need 9. So 1 person in each group. I don't think that really will work, but oh, this is all repeated, so 9 people in each condition. Questions on that? So if you're doing this for the test, you'll have these numbers because you will have run additivity. So you'll have a correlation table saved up in your data screening, and you'll also have epsilon because you'll have talked about Mauchly's. All right. So for a mixed design, under statistical test, it's the one right underneath it. Repeated measures within between interaction. So it's the only one that has both labels on it. So repeated measures between factors is the one you would use if you wanted to do just a main effect. Fixed effects, special, main effects, and interactions is double between. So it's single between, double between, ignoring this one usually, repeated measures in any form, mixed. So they're in the same order that we did them in class. And you will get basically the same table. So we would still determine over here. Alpha power stay the same. Now, number of groups means something else. So it's a number of between subjects levels. So in our study today, we had men and women, so it would be 2. And then number of measurements. Oh, I wrote this wrong. Measurements. So the number of measurements is the number of repeated measures levels. So we had 3. And correlation among representative measures and epsilon are the same thing.
Could you go over the number of groups again?
Number of groups, number of between subjects levels. So for gender, I have male and females have 2. The problem with the way this is laid out is it's not, they're the same screen, but they're testing different pieces, so it's not totally the best layout for repeated within. Right, so the first one we did.
So the number of measurements was?
Number of repeated measures levels. Because number of groups does not make sense for an all repeated design. Right. There are no groups, right? They're all levels. All right. On that one, you did okay, and I need 28 people. So with essentially the same information, we're going to get way different estimates because if it's all within, we're getting more power than if it's half and half.
And on the right side, we did it from variances?
Oh no,
Or
I
still
just
doing direct?
I didn't click it.
Okay.
What did I do a minute ago? So the difference you see in people is due to the difference in design.